So here is a seemingly easy question. Well, it is easy. It says that it starts with the prompt that the time period of a spring mass system executing a simple harmonic motion is given by t equals 2 pi square root of m over k effective. K is the effective spring constant in this case. Column 1 shows the spring mass system executing SHM. Column 2 shows the force constant, the spring constant of the combination, while column 3 represents the time period of the oscillation, and there are 3 questions that follow it. So let's just match the things right away, and then we'll figure out what's next. So in the first case, you have two springs, K1 and K2, and both of these stretch by a distance x if the mass goes down by a distance x. Both of these get stretched by a distance x. So that means that the effective spring is the sum of these two springs. So that means the spring constant is K1 plus K2, one that is right here. So 1 is for 1, and the time period that it represents is P right there. So P, that's the first match. Let's do the second one. The second one is not in parallel, it's in series. And in series combination of springs, we know that it's sort of like the parallel combination of resistors or the series combination of capacitors, whatever have you. So the spring constant in this case is going to be the half of the harmonic mean of K1 and K2. So the thing right here, K1, K2 divided by K1 plus K2. So second one goes to third in the second column. And again, the time period corresponding to it is just going to be well, that's easy. That's just the time period. The formula is given right there. In the third case, this is in series. It's in parallel, and it looks like the series of two resistors or the parallel of capacitors. Again, whatever you like. And thus, the effective spring constant is going to be the sum of both of these. So that's going to be this one. And that means that 3 goes to, in the second column, it goes to number 2. And corresponding to it, the time period is S. If we look at the fourth one, now this is a bit interesting. Since you have these two springs, which are in parallel, so that means the effective spring constant right here, so let me just write K effective 1. This is just going to be the sum of K1 and K2. But then you have another spring, which is in series with this one, and this has an effective spring constant of this just has spring constant of K2. Pardon me, the effective spring constant of first one is K1 plus K1, so that's just 2K1. So now you have two springs which are in series, kind of like this situation, and the spring constants are 2K1 and K2. So obviously, this is the effective spring constant. So the fourth one goes to the fourth row in column 2, and corresponding to it, the time period it has is R. Now, if the time period, the combination of spring mass system shown in column 1, if K1 equal to K2 equal to K prime is this, the correct matching for the system is. So we need to figure out a system wherein this is possible. That seems to be the system S, this one, and that's just B. We just matched it, 3 to S. The spring constant for the combination shown in column 1, 2, I still don't get why they have given it like this, but anyways, becomes twice if K1 and K2 become twice. Then the correct matching shown for this spring mass system is, now, in the cases when you have two springs connected in series, that is in this case, doubling both the constants doubles the effective spring, and it also happens to be the case when you have parallel springs. So, well, let's see which are the correct combinations possible. So this is the correct combination. 2, 3Q is correct. 2, 1P is not correct, 1, 2S is not correct, and 2, 4R isn't. So the only correct one is A. Which of the following shows a wrong matching? So again, this is easy. 2, 3Q, this B is supposed to be right there. So 2, 3Q is correct. So incorrect for this question. 3, 2R. Now this is incorrect, so this has to be correct. Let's just verify other options anyway. 1, 1P is correct, so this is wrong for us. And 4, 4R is also correct, so this is also wrong. So there you go. These are the answers to this prompt.